One, two, three. Hello, everybody. Preparing for the final exam I know is exciting, especially over spring break. So what I've tried to do to keep me from getting bored is force students actually to join me in looking at the problems in the Workbook of Fun. The Workbook of Fun is designed to give you a roadmap on how to study for the final exam and give you some practice problems to work with. Our first problem that we're going to work with, though, it goes back to the very beginning. And we're going to look at this problem one that we have all about cost behavior. And my guests today, representing Sakai, are Grace, Jack, and Matt. All right, so they've been kind enough to do this, do the first problem. And if they do well, they'll do the second problem as well. So it's kind of contingent on how that goes. But nonetheless, we're going to go back to one of the things we saw very early on in one of our very first class periods is this thing, okay? You all should remember this little table. And the whole reason I put it together was because it was setting up y is equal to mx plus b. And so we followed that throughout the semester. It's making a big difference to us even now in some of the special order stuff that we do. So I want to go back through this one more time and make sure we've got this. And so I've given you about 5 or 6 different requirement questions that we'll go through. And those should highlight the things that are probably most important in this particular section. So that's where we're going to start. So Grace, how are you today?
I'm good. How are you?
Well, I'm doing all right. And so what we know is we need to distinguish between the total and the per unit, right? And for the total, if I'm thinking about variable or fixed cost, which one is always constant if I'm looking at the total?
Fixed?
Yep, it's going to be the fixed costs are always constant. And so one of the things she's trying to find out then, if we recognize this as the intercept, this is one of those rows she wants to find out very quickly. Now the other constant we have in our cost equation is going to be the variable expenses per unit, right?
Yes.
And so that's the next piece she's after. So this also is a constant, okay? Because that is going to be the M. And so we need to solve for those two pieces. And so let's figure out how to do that. So Grace, how are we going to get either the total fixed costs or we're going to get the per unit variable? What's your strategy?
So for the per unit variable, oh wait, no. Okay, this is how I want to do it. Okay, so if the per unit fixed cost is $3.
Oh, so you would take the 3.
And then multiply that by the volumes.
Yeah, times the 15, and I'm going to wind up with that 45,000. All right. And so then what did you tell me about the fixed cost in terms of as volume changes? What will my new total fixed cost be?
It's going to be the same.
Be exactly the same. And so that's the thing that you got to stay focused on. Those are always going to be the same. And when we come down here to the per unit amounts, one of the things we know is that the per unit amounts are going to change, right? So this is the whole essence of why we have these problems later in the semester on average cost, because the greater the volume, the lower the per unit fixed costs. And that's one of the reasons we distinguish between the variable and the fixed. Okay, so let's go ahead and fill this piece in. All right, so Jack, let's go ahead and finish this thing off, all right? So you've got the two constants in here, the 45,000, I'm sorry, the 45,000 set up. You're looking for your other constant, which is going to be down in here, right? So you're trying to figure out your per unit variable. And so how are we going to get there?
So for starters, per unit variable cost, it doesn't change with volume like the fixed.
Okay.
Cost. So you're going to take the total variable costs.
So I'm going to take this 100.
And then you're going to divide it by the volume.
Okay. And I'll divide that by the 25,000. and that's going to give me this $4. And much like Grace told me for the total fixed cost, you're telling me that for the per unit variable, it's going to stay the same all the way across.
Mm-hmm.
Okay. And so once you have those two constants, again, you're thinking about this as the cost equation, and that's going to be y is equal to 4x plus 45,000. Okay. So once we get down to this question, you're going to predict cost. So that's why that's valuable to me. Okay. So let's take a look then at filling this thing out, this final piece of the table. And so what we know is that, boom, there we go. So that's our finished table. These again are average costs down here. So Jack, you have any questions how we got any of these numbers?
I do not.
Don't have a question? And do you have a question for me if I know how to get any of these numbers? Maybe how did you get the 60? That's one of my favorites. So I got the 60 by just taking that 4 times the 15, and I got the 60. So you can get there a lot of different ways, but make sure you can do this table. Make sure you realize it's based on this. So we've done 1, we've done 2. Now we need to predict cost at 22,000. So Matt, why don't you tell me a little bit about how to predict the costs, okay? So what do I know?
Well, you'll know that the per unit variable cost is going to be the same because it's always the same, and also 88. The total fixed cost will be the same. So you just take the total fixed cost and divide it by the volume to get the per unit fixed cost.
Yep.
And then,
so I wind up with 133 is going to be my total variable, right? Because it's the 22 times the 4. And then I've got the 45 carried forward. And so I know that my answer to this one is going to be magically and mystically 133. So in total, but the question asks for average cost. Okay, the question asks for average cost, and what I have is the total, but remember this is the average. Okay, does everybody see that? You guys good with that?
Mm-hmm.
What do you think, Grace?
Looks good.
You sure Matt did it right?
I think so.
Okay, you're confident. All right. And so, Matt, I'll give you the hard one, all right? This is the tricky one to be careful with. So what would the cost be? What do you predict cost to be at 10,000?
Can you scroll up? We can't predict it because we don't have what's not within our range.
Okay, so he's saying that 10,000, don't even try it because it's outside the relevant range. And we had said that the relevant range in these kind of problems is set based on the low piece and the high piece in terms of volume. So he's not even going to try it. Be careful, because on one of the exams, that problem was on there. And if you get in a rush, you're not going to pay attention to that relevant range. And so at that point, we're going to come back to Grace. And I want to make sure we can identify the 2 key assumptions underneath this. So Grace, you may not remember these, but I gave you some hints. Okay. So the first assumption, it rhymes with linear compunction. What do you think that one is?
Is it linear function?
It is linear function. Congratulations. You win a prize. So that one's a linear function. And then the benevolent page is
relevant range.
Relevant range. Okay. So you got to remember, as Matt just pointed out to us, that relevant range is going to play a big part in here. So with those, you guys have any other questions?
Don't think.
All right, then. I think we just got through our first one. And if you have any more questions, talk to these folks because I don't remember. So we'll be back with problem 2 in just a little bit. Thanks for playing. Bye.